atoms are so beautiful, and the symmetries are so unlikely to have occurred by accident, that I'm just going to leave empty boxes whenever we have not discovered a particular element. That was gutsy, because it amounted to a prediction. It amounted to say, hey, there's supposed to be one here, an element called radium, that is supposed to have radioactive properties. Nobody has ever seen radium, but I'm just going to leave the empty box here because it has to exist. And of course, Madame Curie, a few decades later, discovered radium and filled that little box, and all the empty boxes that Mendeleev left open, in a very gutsy move, as I said, were eventually filled with elements, and now we have the table of the elements pretty much finished. Oxygen won. But it didn't win because it won at the level of social alliances and so on. It won because there is, in fact, oxygen out there. Does that mean that we have the absolute truth about oxygen? No, it doesn't mean we have the absolute truth about oxygen, because of the distinction I introduced yesterday between properties and capacities. Remember what I said yesterday. Properties are always a list that is finite. A knife is this many centimeters long, it weighs so many, grams, is made out of this material, and it's sharp or it's not sharp, and it has this particular shape, and that's your list of properties. But you can never put in a list all the things that a knife can do. A knife can cut, a knife can chop, a knife can slice, a knife can kill, a knife can pin a note, a threatening note to a door. That it's like a very dramatic gesture, Don't fuck with me. With a big knife pinning it to the door. A knife can do all kinds of different things, depending on what things it interacts. So the list of capacities of what a knife can do is open. Well, the same thing with oxygen. We know the properties of oxygen. We know how many protons it has in its nucleus. We know how many electrons bounce around it. We know the kinds of compounds that it tends to form. That's when it associates itself with hydrogen and forms water. We know that oxygen is a fuel. You throw it into the fire and it increases the amount of combustion. But do we know all the different molecules in which oxygen can enter? Apart from the simple ones like H2O and carbon dioxide? No, we don't know. And we probably will never know, because the number of molecules that oxygen can form is infinite. And if it's infinite, then we will never know all the capacities of oxygen. There will be emergent properties, just like yesterday we had emergent properties at the level of persons, emergent properties at the level of communities, at the level of organizations, then at the level of social justice movements, then at the level of industrial networks, then at the level of federal governments. Well, the same thing with oxygen. There will be emergent properties at the level of the simple molecules it can form. There will be other emergent properties at the level of the molecules that those molecules can form. Then there will be emergent properties about the molecules that those molecules can in turn form, and the space becomes infinite. Just to give you a particular example. Of all the macromolecules that oxygen can form is our genes. Our genes are made of nucleotides, which contain some oxygen, contain some carbon, contain some nitrogen, as well as the proteins that make up most of our body, the proteins that make our hair, the proteins that make our skin, the enzymes that control the rapidity and slowness with which our metabolic processes occur. They all contain oxygen. So it's one of the things that oxygens can do. It is part of one, it should in fact be included into the capacities of oxygen. Now, let's take something simple like a protein. As I said, we are made out of proteins, literally. Well, a protein is simply a chain-like molecule which is made out of a repertoire of 20 different submolecules called amino acids, each one of which has plenty of oxygen atoms around it. And that's it. There's just 20 amino acids. Those are its letters, so to speak. And each protein is a kind of word written with those letters. When you try to figure out how many different